Okay, we're talking about analyzing data in this lesson. A lot of this is probably familiar to you. I think you're probably introduced to it in Algebra 1. So mean, median, and mode, three terms you're probably somewhat familiar with. Commonly used to help us describe data sets, analyze things. So mean is just the average, all right? So you remember how to solve or find average. Add up all the values in a data set, divide by the total number of values, and that gives you an average or the mean. Median, on the other hand, is the middle value of a set. Okay, you think about what the median in a road is, that part in the middle that you're not supposed to drive on. Okay, so the middle value. How do you find the median? Order the set from smallest to largest. So you've got to reorder the set if it's not already in numerical order, and then you just find the middle value. Okay. If the set has an even number of values, then there's going to be two middle values, you just average them. Mode is the most frequently occurring value in the set, so the one that shows up the most often. Okay, let's go look at an example. Find the mean, median, and mode. Now I've already written some things on here just to save time in this video. So here's a data set they gave us. First thing I did was reorder it from smallest to biggest numbers. Okay, smallest to biggest numbers. Now the mean came out to be 91. How did I find that? Well, I added all these numbers up and I divided it by the total number. Now there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 numbers in this data set. So I added all these up, divided by 9, and that's where I got 91 from. Now I drew a box around 95. That's the median. It's the middle number in the data set. Now if they're not in order, you could go to the middle of that number set, but it's not going to mean anything. They have to be smallest to biggest. So just find the middle number. This was an odd number set, so 95 is the pure middle. And mode, well, notice there's a 97 and a 97. 97 showed up twice. There was nothing else that repeated. So in this case, there's a 97's our mode. There doesn't have to be a mode, by the way, in a number set. Some of them won't have repeaters. Some could have things that repeat the same number of times, so that we could call that bimodal or things like that. Okay, let's talk box and whisker plots. You've probably seen these before. This is a way to visually represent data set. 5 key points show up here. You've got a minimum value, Q1, we call it the first quartile. The median value we already talked about. That's the same as Q2, by the way. Q3, the third quartile, and your maximum value shows up. Okay, sometimes we call that a 5-number summary. Now along with that, we can get outliers sometimes in a data set. What's an outlier? Just like it sounds like. It's a data point that varies substantially from the other values. Now we're not going to go into a lot of detail at this point. You know, how do you numerically find an outlier? Just if you see a number that looks like it's way out there from the other ones, we're going to call it an outlier for now, okay? What does a box and whisker plot look like? Let me just show you a quick example. So there's a box, and then it's got these whiskers out here. The minimum value is out here at the end. The maximum value is on the other side. The median is right in the middle. That's what this line represents. Q1 is right here, and Q3 is up here. So what this represents is 25% of all your data is going to be below this Q1. So we're really dividing it up into quartiles, 25%. So 25% of our data is right here, 25% in here, and then the other 25% out here. Now if you got something, you know, where you got a whisker going way out, something like that, then hey, this guy out here is an outlier. Okay, that's just a visual way. Maybe we could see that. Okay, let's go make a box and whisker plot. Create a box and whisker plot. Now here's a data set. To save time, I've already ordered it smallest to biggest, okay, because you have to do that. So let's recognize what we've got. Okay, and I'm going to make a number line. We've got 7 up to 29. So you just sketch a number line, and I'll just start at 5. To make it easy, I'm just going to go by 5, 10, 15, 20, 25, 30. Okay, and of course we got numbers in between there. Let's identify some key things. So like 7 is going to be right in here. Hey, there's our minimum. 29 going to be somewhere out here. There's our max. So we've identified those two things for our box and whisker. The median, okay, let's find the median. It's at 19. Again, I've already done that. I divided this number set in half. So 19 is the median. So it's about right in here. I'm going to draw a line for that. Now, how do I find Q1? So this is Q1, this is Q3. I've already identified them, but how did I find those? Well, you find the median, and then you just find the median of the lower half of data and the median of the upper half, basically. Okay, you're just dividing that half into a half again. So 12 is my Q1, so it's like right in here, let's say. So let's draw a line there as well. And 24. So let's go somewhere over here. Now let's make a box out of this middle stuff. Again, this is kind of hard here with my digital sketch pad, and then let's connect out to our whiskers. So again, this would represent Q1, that'd be Q3. We've got our min out here, we've got our max out here. Okay, so they're going to show you some charts and match a data set to a box and whisker plot. Hopefully not too bad. Look for some key values and we ought to be able to match those up. Alright, let's talk percentiles. Percentiles are used all the time with testing, with body size, like hey, I'm in the whatever percentile for height or weight. There's all kinds of places percentiles are used. They describe locations within a number set. For example, if you scored in the 80th percentile on the ISAT or ACT or whatever, that means your score is as high or higher than 80% of the students tested. It doesn't mean you made an 80% on the test. It means your score is higher than 80% of everyone who tested, okay? Here's a little relationship I'd encourage you to write down. So the number of values in a data set times the percentile equals the number of values below that percentile. Okay, let's look at a little example. Find the 20th percentile for a data set. Well, here's a bunch of numbers they gave us. I've already reorganized them, lower to bigger, okay, smallest to biggest, like we've done in these other things. So you always need to do that if it's not already. What's the 20th percentile? Well, using this relationship, there's 10 total values here if you count them up. If we do times 0.2, because that's 20%, you would get 2. So there are 2 values below whatever the number that's the 20th percentile. Well, that's going to be this guy right here, right? 2 numbers below it. So we could say 59 is at the 20th percentile. If I wanted the 70th percentile, I'd count over. There'd have to be 7 numbers below it. So 1, 2, 3, 4, 5, 6, 7. So 73 would be the 70th percentile for this particular data set. Okay, obviously it depends on a data set. Okay, I hope that helps you kind of get started in this lesson today. As you go through things, these will give you some good examples, I hope, to help get you started.